Charge-coupled device, or CCD. In a digital camera, the job of the film has been taken over by what is called a charge-coupled device. This consists of millions of tiny photosites, which generate and store charge when photons land on them. The photons free up electrons, and so the more photons that land on a photosite, the more electrons are released and stored on that photosite. Each photosite then passes its charge along individually to be recorded, so an image can be produced. Here we have a light source and a much simplified charge-coupled device with only 16 picture elements or pixels. Photons from the light source will hit different pixels of the camera, freeing up electrons. So here we have the charge-coupled device with the numbers in each pixel representing the amount of charge stored on that pixel. We now need to gather the data, and that is done like this. This number will be transferred across, and followed by the next one, and the next one, and so on. Then the numbers can all drop down a row, and we continue. They drop down another row, and continue. And finally, the last row. So we've converted the image on the charge-coupled device into a string of numbers. The greater the number of pixels a camera has, the better its resolution, meaning smaller details can be seen. A 5 megapixel camera will have 5 million pixels. If these cover an area on the CCD of 2 square centimeters, each pixel will have an area of 2 square centimeters, which is 2 times 10 to the minus 4 square meters, over 5 million for the 5 million pixels, giving each an area of just 4 times 10 to the minus 11 square meters. If these pixels are square, each will have a side length of the square root of 4 times 10 to the minus 11 square meters, which is 6.3 times 10 to the minus 6 meters. CCDs were first used for producing images in astronomy. This involved being sensitive to very low light levels. Photographic film has what is called a quantum efficiency of around 4%. This means that only around 4% of the photons landing on the film actually contribute to producing the image. CCDs, on the other hand, can have a quantum efficiency of around 70%. The human eye only has a quantum efficiency of around 1%. A CCD also has much more linear response to increasing light levels than photographic film, meaning a doubling in intensity will lead effectively to a doubling in image strength, which isn't always the case with photographic film. A CCD also has a digital output that can easily be processed by computers to enhance the image. To produce a coloured image, you can use 3 CCDs, one recording the red light, one the blue, and one the green. These can be then put together in their relevant intensities to produce an excellent image. Here the light from the source passes into the prisms. Some light will pass straight through this green filter to be recorded by the CCD for green light. Some will reflect at this interface, passing through the red filter to this CCD, and some will reflect at this interface, passing through a blue filter for this CCD. A cheaper method, only requiring one CCD, is to cover each pixel with either a red, a blue, or a green filter. Information from a pixel and its neighbours allows a close estimate of the correct colour for that region. A common arrangement is what is called a Bayer filter, shown here, where we have rows of blue and green, followed by rows of green and red pixel filters. This has as many green filters as the red and blue combined, because the human eye is more responsive to green light, so more information in this part of the spectrum is needed.